I hope you had a chance to draw a bottle in Illustrator in preparation for Project 8. We will be drawing a bottle in Illustrator. This is a photograph of bottles. This isn't a drawing. But I ask you to draw a bottle in Illustrator, taking no more than 15 to 20 minutes to do it, and it's only fair that I also do that. This is my bottle. Hopefully your bottle looks like my bottle. Not necessarily the same shape, but you can draw a bottle like this in Illustrator. It's not that difficult. Let's talk a little bit about perspective. Perspective is a type of projection. There's also something called axonometric projection, which is not a perspective projection. Axonometric projection is a type of orthographic projection used for creating a pictorial drawing of an object where the lines of sight are perpendicular to the plane of projection and the object is rotated around one or more of its axes to reveal multiple sides. That's not perspective drawing. Here are three types of axonometric projection. Trimetric projection, the x, y, and z axes are measured differently. Dimetric projection, where the x and y axes are measured the same and the z axis is measured different. So angle A equals angle B. Line AB is the same length as line AC, but not the same as line AD. In isometric projection, everything measures the same. X, Y, and Z axes are all measured the same. So a cube drawn in isometric projection, each direction of the cube, the x-axis, the y-axis, the z-axis, all measure exactly the same. That's isometric. These are examples of isometric projection. Isometric became popular for architecture starting with the Bauhaus in the mid-1920s. This is actually an isometric projection of the Bauhaus building in Dessau. This is an exploded view. This is another exploded or separated view. Isometric projection of the Bauhaus building in Dessau. This is a drawing by Herbert Bayer, an isometric projection of, I believe that's probably a student living space. This is a kiosk designed by Herbert Bayer. This is a home interior concept by Herbert Bayer. And this is a landscape architecture. And all of these are isometric projections. In perspective, things don't all measure the same way. You have a horizon line and you have vanishing points where parallel lines in an object converge to the vanishing point on a horizon. This is a two-point perspective where there's a left vanishing point and a right vanishing point. This is an example of a projection, how the drawing is projected onto the drawing plane. This is the viewer, this is the eye or the camera, this is the object, and lines of sight to the object give you these points. And then the parallel lines of the object converge to the horizon line at a vanishing point on the left and a vanishing point on the right. If you're in front of the Auditorium Theater on Ida B. Wells Parkway, looking down the arcade, this is a one-point perspective where everything vanishes to a point directly in front of the viewer. This is a view north on Wabash Avenue, about a block north of the 623 building, half a block north, I think. This is a one-point perspective where everything converges to the center of the street down at the horizon line. This is a view from the 8th floor of 623 South Wabash. The view is at an angle to the objects, so the parallel lines of the objects converge to a left vanishing point at the horizon and a right vanishing point at the horizon. This would be a three-point perspective because the Sears Tower in the back is converging to a vanishing point above. This one, where most of the buildings are centered on the line of sight, everything is two-point perspective converging on a left and right vanishing point. If you're looking up at a building, you have a three-point perspective where the parallel lines that are in the z-axis converge upward. The parallel lines on the x and y-axis converge left and right. When drawing a bottle, you want to avoid looking like a cubist. This is a Corbusier cubist painting. That's a still life. There's a bottle. It could be a stack of dishes. I'm not sure what that is. A guitar. There's another bottle in the back. What you notice about the cubists is that they are showing things simultaneously from more than one perspective. I'm looking down at the top of this, but I'm looking at the side of it. I'm looking down at the top of the bottle, but I'm looking at the side of it. You'll also find some drawing errors that are acceptable if you're a cubist that you wouldn't do if you were trying to do an accurate drawing of something. If you look at the base of this bottle, it looks like the shape of an eye. It comes to a point at the left and the right. Bottles don't actually do that. The bottom of the bottle in three-dimensional space would be an ellipse, or close to an ellipse. In an isometric projection, it would be an ellipse. In perspective, it's slightly different from an ellipse. When I was learning perspective, this is how we understood circles in perspective. This is a circle inside a square, and there are guidelines vertically, horizontally, and at 45 degrees in either direction. In perspective, it looks like this. It's not a true ellipse. An ellipse would look like this. So you see, in perspective, there's a foreshortening of the curves so that this looks somewhat flatter than this closer front curve where it's more spread out based on the square that it's sitting on in that perspective. So whatever angle it is at, it's never quite the same as an ellipse. A round bottle doesn't have any pointed corners. Here's the way a cubist draws a bottle with these pointed corners. In reality, you know that a cylinder, which is round, has parallel sides which, in a perspective drawing, should be tangent to the elliptical shape that represents the end of the cylinder. I'll open my transform palette and select this object, and the bottom reference point, the bottom is at Y 430. And if I select the ellipse, the center reference point is at 430. So this line is exactly tangent to that ellipse. So that's what you expect. Now, this isn't actually a problem in the 3D that I'm going to show you, but that's one of the ways that I know whether or not someone understands 3D drawing and whether or not they use the 3D method I'm teaching them or if they try to draw it some other way. Cubists draw objects or people from several perspectives and combine the perspectives into one image. We don't do that when we're trying to do an accurate drawing. You're probably wondering why this is here. This is Enrico Fermi and other physicists and mathematicians performing the first controlled chain reaction under the bleachers of Stagg Field at the University of Chicago in what had been a squash court. And the reason this is here is because I'm going to show you something in Illustrator that is the equivalent of unloosing atomic energy and destroying the world. At the time that they did this, they didn't know if they could control this reaction or if there was a chance that they would end up blowing up all of Chicago and possibly the whole planet and maybe the whole universe. So I'm going to warn you about something you should carefully avoid in Illustrator, and if you don't carefully avoid it, you're really going to make a mess of the project. Now, how does one draw a bottle? Well, the way I drew my bottle, going back to Jon Gnagy's Learn to Draw book, if you can see it, you can draw it. If you understand what you are seeing, what objects you are seeing, what shapes have been assembled to make what you are seeing, then you can probably draw it. And the same is true with 3D and Illustrator. So, for example, I don't have a bottle here, but the closest thing would be this jug. And you'll notice that it's a truncated cone, a sphere, and a couple of cylinders. And that's all there is to drawing that particular shape. When I drew my bottle, I did the same thing. I said, well, I need a cylinder at the bottom, I need sort of a spherical shape, and I need some other cone or cylinder shapes to make it look like a bottle. If you push the wrong button in Illustrator when you're making 3D, it's sort of like when Homer went through the wall and ended up in a multi-dimensional world which he, as a two-dimensional person, was unfamiliar with. I'm going to show you 3D Revolve in Illustrator. It's under the Effect pull down. Once you create something with 3D Revolve, you can never go back to that pull down and push that 3D Revolve button again. Because what happens is you are telling the program to take something you have already made into 3D and make its components into 3D also. And it's like you're trying to tell it to make a 9-dimensional object. You don't understand what a 9-dimensional object is. I don't understand what a 9-dimensional object is. And your computer can't figure out what a 9-dimensional object is. So you can put it into something like an infinite loop where it can never get itself unstuck trying to make that object. It could be like that, it could be worse.